Hi, welcome to Solving Equations with Fractions. Let's take a look at this top one. We want to get x by itself, and there's a 4/7 with it. Well, this is really easy. To get rid of 4/7, I'm just going to flip it upside down and make it 7/4. In math, this is called the multiplicative inverse. And then we're going to multiply times the fraction that was already here. And if you cross cancel, all of these become 1. And 1 times x is x. So it's a really easy way to get rid of the fraction attached to the x. Now, the flip fraction, we're going to take it to the other side because we want to do the same thing on both sides of the equation. And again, we're going to multiply. If you want, you can put a 1 under the 12. And we're going to look for cross cancellation. So 4 goes into 12 3 times. And 3 times 7 is 21. And 1 on the bottom, which is just 21. And there's one negative sign. And so we're going to use our rule for multiplying and dividing with negatives, which you count the signs. There's 1. 1 is an odd number, and so that makes your answer negative. Let's look at this next one underneath. This one has a fraction attached to the x again, similar to the one above. But we also have a -9 on the left side of the equal. Well, this is called a two-step equation. You always want to complete all of your addition or subtraction first. So let's move the 9 to the other side by taking the opposite. So we're going to add 9 on both sides. This gives us 7/8 x, our equal sign, and 5 plus 9 is 14. Now again, to get x by itself, I'm going to use the multiplicative inverse. I'm just going to flip this fraction, very easy. Multiply both sides by the flipped version. Those all cancel out and become x. And then now I'm going to use cross cancellation. 7 goes into 14 2 times. And 2 times 8 is 16 with the 1 on the bottom, which is just 16. So this is really pretty easy. Let's try another one. In this problem again, we want to get x by itself. So we're going to flip this fraction, which is called the multiplicative inverse. We're going to multiply this side, the left and the right side, by the flip fraction. So they look identical on the outside. That's a good thing to do, is just check that to make sure you read it right. These all cancel out and become x. And then now I'm going to look for cross simplification, cross cancellation. So 11 goes into 22 2 times. And then I can't do anything with the 4 and the 17. So 4 times 2 is 8. And then 1 times -17 is -17. And that's the answer to that one. So these look hard, but they're really not. But they do look kind of confusing at first. And after you work a couple of them, they're easy. Alright, so let's take a look at another way to solve equations with multiple fractions. In this problem, we are going to actually get rid of all the fractions. It's going to be much, much easier. This is called clearing an equation of fractions. So what I want to do is I want to look at the 15, the 5, and the 3, all of the denominators. So another way you can kind of think about this is if you were going to add all of these, like if I make them fractions with the 1 on top, the 15, the 5, and the 3, the 15, the 5, and the 3, what would be the common denominator that you would use? Well, it would be 15. So we're going to use that same method of finding the least common multiple, or the least common denominator for these three fractions, which we said it's 15. Okay, so what I'm going to do is I'm going to multiply each term by 15. I have 1, 2, 3 terms. Don't forget this side of the equals. Okay, this first one, I'm going to write it underneath so you can see what it looks like separately, and then we'll go back and do it this other way that I like. Okay, so I said I'm going to multiply these. So 15 is 15 over 1, and when I multiply, these cancel out, and it leaves me with 11, and it's negative x. So I just got rid of this first fraction. That was pretty cool. All right, now I'm going to take the second term, 4/5, and I'm going to multiply it times 15. I could write it like that, or I could write it like that. They're both multiply. So you can think 15 over 1, 5 goes into 15 3 times, and 4 times 3 is 12, and it's positive. There's a plus sign. We aren't using any negatives here. Okay, so that took care of that one. Now this one, I'm not going to write it underneath for you. 3 goes into 15 5 times, and you're going to multiply the 1 times the 5, and you're going to get 5. So if you need to work them underneath at first so that you can kind of see how that method, that process works, go ahead and do that. Now we have an easy equation to solve. This is a two-step. So in a two-step, what you want to do is eliminate all addition and subtraction first. So on the equal sign, on the left side, I have a positive 12, and I want to get rid of that by doing the opposite. That leaves me my negative 11x. Those go away. And then I combine these. That's going to be negative 7. And now I want to get x by itself. So I'm going to take whatever was in front of x, negative 11, and I'm going to take that on the other side through division. That cancels out, and I get x equals negative 7 over negative 11, and 2 negatives. That's even, so that means that that fraction is going to be positive. Let's take a look at another one. In this problem, I have a denominator of 13. And we can get rid of that. So if we multiply each of these terms by 13, alright, so this one on the left side, 13 goes into 13 one time, and 1 times 2 is 2. 13 goes into 13 one times, and 1 times 8 is 8. I'm just going to drop the x down, and then 13 goes into 13 one time, and 1 times 4 is 4, and it's positive. Now I'm going to subtract 4, so I can get that 8x term by itself, which I did. The 8 is attached to the x through multiplication, so we want to undo that by using the opposite, which is division. And then we're going to simplify this fraction, and it's going to remain negative. Let's try another one. This problem is similar to the first one that we had, because we have different denominators. We have an 8 and a 10. So if you counted by 8s and you counted by 10s, the smallest multiple that you would find that they have in common is 40. So that's what we're going to use. We're going to use 40. We're going to multiply each of these terms by 40. Again, it's a really common mistake to forget to multiply 40 on the right side of the equal sign where this term is all by itself. So just think I've got 1, 2, 3 terms, so I've got to multiply each one of those by 40. Okay, 8 goes into 40 5 times. Now you're going to take that 5 and you're going to multiply it times the numerator. So 5 times 7 is 35, and we're just going to drop our x down. Alright, now 10 goes into 40 4 times. And 9 times 4 is 36, and there was a minus sign in front of that, so I just dropped that down. Okay, and then 8 goes into 40 5 times, and 5 times 1 is 5, and there was a negative sign in front of that, so I'm going to keep that negative sign. Now we have an easy equation to solve. Again, it's a two-step, so we want to complete all addition or subtraction first. So we want to get rid of the minus 36, so we take the opposite. That cancels that out. We get 35x equals, and that looks like 31, and we would divide both sides by 35. And we get x equals 31 over 35. And this is how you solve equations that have fractions by clearing. It's really pretty easy, so give it a try. And thank you for watching my video today. Check out my others online.